This is the program?
This is the actual program, so it's about 300 lines of position data, and you have to step through and you tell the robot where to go at every step of the process. And there's special instructions like opening and closing the grippers, wait for something to happen. And if it were talking to other robots, in coordination with other robots, they would talk to each other, and this is where you'd program all that in.
Okay.
How fast to go, how to get there, what orientation is all contained in that information at each line of code.
Okay. Okay.
You can see the RO3 off means grab it. These are pulling it up, and so what you can do is step through the program. So at each line, you step through it, and that's what somebody did, is programmed it in X, Y, Z. And then you tell it, okay, now what do I want to do? I want to move it here.
Excellent.
And you work your way through the program.
And this, I mean, the robot is working with dominoes here, but the application is obviously, this could be a torch, this could be some kind of precision cutter, this could be something
A
working
laser,
at
a welder, a painting, gluing, and material handling is very common. So this actually would directly correspond to, instead of picking up dominoes, you're picking up parts like in the medical products or the software industry. You've got a lot of little parts that you need to move, and you would move them very easily and quickly to exactly where you wanted to need to go.
Okay.
You know, picture in a medical device or a software, all those little soldering points you have to put in that have to be extremely precise and extremely tiny. A man can't do that.
Right.
So you would have the robot with a little soldering gun on it and put it precisely where you need it to go, and it'd be right every time.
This is one of my favorite phases right here.
Oh, I know why. My fixture wasn't in right.
Ah, okay.
So that was a man error.
Exactly. Yeah, that's an interesting part because it demonstrates, number one, that's exactly why robots won't take over the world.
That's right.
Number two, there are a lot of external conditions. The robot may be doing its job perfectly, but the things around it are not in the right position. So I imagine the students have learned a lot of hard lessons with that kind of example, huh?
Oh, absolutely. They've had things set up that work perfectly the first time. They go to demonstrate it in class, and it fails because the table isn't right, or you move something different, or many things in the environment could have changed.
Yeah, good deal. Probably the table. We bumped that table
Yeah.
earlier, didn't we?